Good morning. I'm Jeff Hammond, Executive Director, International Ground Source Heat Pump Association. Thank you so much for joining us for our IGSHPA Dig Deeper webinar for October. Our sponsor for this webinar is Climate Master, a manufacturer of water source and ground source heat pumps. We thank Climate Master for sponsoring this webinar, and we will get started right now. So before we turn this over to our speakers, just have some quick IGSHPA news. If you like these webinars, we are accepting abstracts now for presenters for 2025. So if you would like to submit an abstract, just go to IGSHPA.org, click on that training and events button, and you'll find an abstract link in that section. So we'll take those right now for 2025. That will help us with some planning. We'd love to have your presentations. We're also accepting advertising for our 2025 Town Hall and Dig Deeper webinars. That's on the website under media, I should say. We changed that menu, and you'll find Town Hall and Dig Deeper webinars under there and advertising information. If you're looking for CEUs for your certification renewals, these Town Hall and Dig Deeper webinars are eligible. If you would, just include your name and email in the chat, and we'll keep track of those. There is a new option. This webinar is being recorded. So if you happen to be watching this webinar at a later date, if you're not watching it live, you can provide this code and you will get credit for watching this webinar. If you're joining us live, no changes. You don't need to enter the code, just your name and email. But if you are watching this as a recording, you'll want to make sure and enter that code. I'm going to keep my updates quick today because we have 14 speakers. And so I want to turn it over to our presenters here pretty quickly. Just a little bit of housekeeping. If you're not speaking, please mute your mic. And if you have questions, just enter those into the chat or the Q&A. Some people have difficulty with the chat for security reasons. Some of their companies have the chat locked down if you're not part of that company. So you may be able to use the Q&A if that's the case. And if you can't use Q&A, raise your hand, and I'll look for your hand, and we'll unmute your mic. But that's the easiest way to handle that. Any questions in the chat or Q&A, and then when we're finished today, I'll read those questions. You might get a message that looks like this. As I mentioned, there's some settings that may be needed and so that you can participate in the chat. So you may have to click OK in order to join that chat. If you can't use chat, the Q&A is at the top of your screen, and you can use that as well. As I mentioned, if you can't use either, just raise your hand. Just a quick disclaimer and potential conflict of interest, and then we'll get our presentation started. The upcoming presentation represents the opinion of the presenter, in this case, multiple presenters, and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA Town Halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is a presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So now we're ready to start our webinar. Thanks again for joining us, and thanks Climate Master for sponsoring this webinar. We'll be turning this over to the task force members here shortly. We have 14 different task forces on this standard. This is the CSA ANSI IGSHPA C448 standard. If you're not familiar with it, I have just a couple of slides here on a little bit of history. But this is a binational Canada and US standard. It's been around for quite some time, and it's for the design and installation of ground source heat pump systems for both commercial and residential buildings. So this is really a key to consistency for our industry, the minimum requirements to have a successful design and installation of a system. So that's why we're spending so much time. It is super important for the growth of the industry. Just a little bit of history before we turn it over to the task force chairs. The CSA standard has been around for quite some time. It started as a C445 for residential and C447 for commercial. And these were Canadian-only standards at the time. So they've been in use for a long time. They're part of the C448 is part of the Canadian Building Code. And so it's had quite a lot of history here. In 2016, it became a binational standard. IGSHPA, as well as PPI, NGWA, and too numerous others to mention, participated in these updates. So the 2016 standard became a binational CSA and also ANSI and IGSHPA, three designations, C448. So that's the current standard. We've been working really since 2019 on updating this standard with what we're going to talk about today. So we're thrilled to announce that early 2025, we will have the next edition of CSA ANSI IGSHPA C448 published as a 2025 edition. And you may realize this, or you may not have heard, but as soon as that C448 standard is published, IGSHPA will sunset the 2017 standards. So that will be the official standard for the industry once the 2025 edition is published. Just to give you a little bit of background here. So we're going to go with each of the task force managers. And before we start with the task forces, also I'd like to have a few words from our project manager, Andrew Kostruba with CSA Group. Andrew has just been incredible. I don't think we could have pulled this off without Andrew. He knows not only the CSA processes, but he knows our industry well. And so we'll start with him. Then we'll talk about the general section, design and installation for residential, commercial, and so forth. You can see these. I won't read them to you, but these are all the chairs for each of these task forces listed here. So each one of them will be going through those their own task forces. You can see some more here, 8, 9, and 10. There's an annex that's new to the standard, the wastewater energy transfer systems. We have a piping task force, heat transfer fluid, and last but not least, thermal conductivity task force. So that's the plan of action for today. Each of our task force chairs will go through their sections. And at the end, we'll have time for questions, hopefully. Because it's such an important standard for our industry, hopefully you'll have some good feedback and then some interaction with the task force chairs. We will be having each presenter introduce themselves when they speak, and we don't have any slides for after this point. This is the last slide you'll see. So the person who's speaking will have their camera and microphone on, and that'll be the task force chair. And everybody else will have their microphone and their camera off. So hopefully that all makes sense. I'm going to stop sharing my screen and turn this over to Andrew Kostruba. Andrew, if you'd like to just get us started on the standard, that would be great.
Yeah, for sure, Jeff. Hello, everyone. My name is Andrew Kostruba. I'm, as Jeff mentioned, the project manager for the C448 standard from CSA. I apologize in advance. I will not have my camera on for today. I've been battling a cold cough for the past week, so I'm not ready for prime time. So for the benefit of everybody here today, I won't turn on my camera. You'll get to look at a younger and healthier picture of me as my avatar. So right now I'm just going to give a quick overview of CSA as a whole, because not everybody might be familiar with who and what CSA Group is. And then I'll have a few extra words kind of more related to the C448 standard. So CSA Group is based out of Toronto, Canada. You might have heard of us before going by the name of Canadian Standards Association, but really we are a global organization. I'm going to talk about the standards development side, since we do have a testing, inspection, and certification portion of the business, but our standards development side is really a member-driven, private, not-for-profit organization. We have 10,000 members who volunteer their time to develop over 3,000 standards across 1,000 committees, over 12 areas of focus. And that includes electrical, construction and infrastructure, healthcare and well-being, power generation, such as nuclear power plant standards, worker public safety standards, and really our flagship document is the Canadian Electrical Code. We've been an organization for over 100 years now, and we are also accredited by Standards Council of Canada to develop national standards of Canada. And we're also accredited by ANSI to develop American national standards. So we have the great benefit of being able to publish C448 as a binational standard. On the C448 side, diving a little bit deeper here, as Jeff mentioned, we had a huge number of task forces. I'd like to thank all of our volunteers from the get-go. We had over 75 individual members across all of our task forces volunteer their time to develop and have their say in the development of the standard. This standard has been under development for a number of years now. I can personally say that CSA staff have now put in over 1,000 hours of work into that standard. With regards to where we are in the development process, any day now I'm expecting for a draft to come across my inbox for to be balloted for approval by our technical committee on grounded water source heat pumps. And after that, we'll just be kind of finishing up doing our final accreditation steps before publishing the standard in early 2025. We're targeting February 2025, but that's still, we won't have a concrete date until December or January. So again, thank you to all of our volunteers, and I think that is my few minutes up, and I will kind of kindly pass it on to the next presenter.
Thank you so much, Andrew, and thank you for your leadership. It looks like Mark Metzner is up next as our General Section Task Force Chair, and I do want to mention that full disclosure, I'm chair of TC 423 and the C448 subcommittee, and Mark is vice chair. He's been incredible in leading all this work, and so we turn it over to Mark for the general section.
Thanks, Jeff. I appreciate it, and thank you everyone for attending this morning. As Jeff mentioned, it's a very important standard. It will guide our industry north and south of the border for the next 5 years. So it's a pivotal document, if you like, and a bit of a playbook. Just from the general section point of view, I think it's important to understand a few things. One, a standard is covering the minimum requirements. It's not how great you could make something. It's like the minimum. This is the bar you must reach to be compliant with the standard. And it is, wherever possible, performance-based. But there are areas that are prescriptive. I'll touch upon it briefly, and I'll let some of the other task force chairs get into more of the detail. From an overview point of view, there's a couple of issues I think that have to be addressed, and that is the 2016 edition, which was the first binational edition, needed review, and that's obviously from two aspects. One was there is a prerequisite to do so, and there was a lot of back and forth on what's the best approach for the format. And what I'm getting at is the 2016 edition had a number of task force or sections, and what we realized after publication and after use for some time, there was a fair amount of redundancy in all of the different sections. What I'm getting at is like vertical section, horizontal section, etc., had duplication, and sometimes there was contradiction. So part of what we have done with the 2025 edition is to eliminate that. And the prerequisite, if you like, was get as much of the same information, if you like, into the general section so that there was no conflict or contradiction. And the criteria for that was if any particular topic touched more than two of the sections, and what I mean by that is the different configurations of ground heat exchangers, vertical, horizontal, surface water, etc., then that topic would be moved into general so that we had consistency all the way through. So that's been done. What that ends up doing is making a bit of a shorter standard from the 2016 on most topics, but because, as Jeff mentioned, we have also expanded the standard, that it is actually a longer standard, but there's more information, more content around different types of heat exchangers, with an example that Tony Amos will touch upon later with energy pile foundation heat exchangers, wastewater, that Lisa Mullen will look at under an annex, as well as district that is in the body of the standard. Excuse me. There was areas that we really want to concentrate upon that needed absolute clarity, and Terry Proffer will touch upon thermal conductivity testing. Lance McNevin will look at the piping materials. Jerry Lewis from the UK will look at heat transfer fluid for systems. And one of the areas that we had to really address was the hydrostatic pressure testing. We've been defaulting to ASTM F2164, which is actually technically not feasible. And I'll touch upon that very briefly in a few minutes. As an overview, the general application section, again, covers minimum standards for equipment, material selection, site survey, system design, installation, testing, verification, documentation, commissioning, and decommissioning for all of the sections where applicable. There's an overview of the scope in the general section. Reference publications are very extensive. We will not be duplicating within the standard other reference publications. We point you to that. There was a fairly exhaustive relook at all of the definitions, and that's a long section, but was absolutely necessary. So we had clarity within the body of the standard, what we are talking about. There's going to be regional differences and things that are different between north and south of the border, but we want to have a commonality with respect to what we are talking about, so there's no misunderstanding. Pardon me. I said we wanted to like site survey requirements, design, installation, testing, verification, decommissioning, and abandonment. Within the definitions, just a couple of quick notes. There was a lot of back and forth or talk, with respect to designer versus engineer, and we settled on a definition for designer, which also includes professional engineers. And quickly, I'll read the definitions. I think it's important. Is the designer is the entity legally responsible for the ground source heat pump system design. So that could be a contractor, as an example, that's competent in doing design, but they ultimately become the legal entity responsible, or a professional engineer. Excuse me. One of the areas that caused some friction or heartburn, if you like, from the last edition was the area of setbacks. And it became really a hot potato, if you like, because when we started to look at where the setback distances came from, as we dug deeper into it, there was not a great deal of technical justification. So we redid the language, if you like, so that the designer, again, that's that legally responsible entity, has to take into consideration things such as property lines and easements or encroachments, foreshore requirements, as an example for surface water systems, the distance from septic tanks or subsurface sewage leaching fields, etc. And the onus is going to be on the designer to produce the design that is workable and work with the authority having jurisdiction on any setbacks from any particular infrastructure. There's going to be different parameters when you get into a highly, densely populated urban area versus a farm, as an example. And being prescriptive, we realized, was not the best avenue. Excuse me. When it came to things such as piping materials, and I won't step on Lance's toes, there are some issues to look at. That, again, this is an area where things were very prescriptive, and by nature, it had to be. We don't want to have garden hose going down a borehole. So we have, high density polyethylene pipe as a compliant material, polyethylene raised temperature and PEX. And there's going to be a different issue when it comes to DX piping systems, but I'll let Craig Busher touch upon that in his section. As a note that's important, CPVC and PVC is no longer listed as an acceptable material for field headers, manifolds, indoor piping associated with ground source heat pump systems. Minor area, but an important one, was the locating and marking of where horizontal piping and or boreholes are physically located. It's important because should there be an issue, you have to have a way to get back into that system, if possible, the ground heat exchanger to find it. So we've touched upon how that would look. Non-destructive systems. We have like radio frequency and other detectable markers, tracer wire, detectable tape. There are options, and it depends on the design and application. Within the heat exchange, heat transfer fluids, Jerry Lewis and his task force went to a great deal of depth of knowledge and detail, and I'll allow Jerry to expand upon that, but quickly. This is under clause 5.7. It goes to like system preparation, the general requirements, cleaning processes, disinfection processes, water quality requirement and analysis, corrosion inhibitors, scale inhibitors. It's very intense, and Jerry and his team did an absolutely great job on that one. The one area I alluded to earlier, and Jeff, I will conclude very quickly here, was around pressure testing. And we had to modify, and between the piping task force and a few other task force members, we did a bit of a modification, if you like, to ASTM F2164, where the 2016 standard basically defaulted to that. A number of task force members, identified it's actually not possible to adhere to that strictly because of where pressure testing under F2164 is supposed to be able to occur at the lowest point of a system. That's more geared towards horizontal water distribution systems than it is for ground heat exchangers. So we had to modify that. I think an excellent job was done of the modification that keeps the spirit of F2164 and the technical requirements, but adapts it to ground source heat exchangers. The one area that we did kind of add was a optional testing, hydrostatic testing regimen, so that individual boreholes or laterals could be tested quickly, but do a integrity test, if you like, prior to backfill or handing over from one contractor to another. What I mean by that is you can have contractors that are going to do the the borehole drilling, piping, and grouting, and then they may hand over to another entity for the lateral tie-in. We want to have a procedure that was not time exhaustive, but would produce the integrity test required, so that that handover went smoothly and there would be no finger pointing into the future. On that note, Jeff, I think I'm going to pass it over to the next presenter.
Thank you so much, Mark. And just to clarify, if you weren't here right at the beginning, when the person who's speaking will have their camera on, so there is no presentation for this webinar. It's more of a panel type discussion. If you're wondering where that presentation is, it's the person with their camera on. They'll introduce themselves when they start speaking, and each one of the speakers is a chair of that particular task force. Another thing to just maybe point out, Mark's section, the general section, that's really everything that's not laid out specifically in one of the other sections. And part of our process in updating C448 was to look for clauses that were in more than one section. And so I guess you could say we threw a lot of stuff over the wall to Mark. And his task force was responsible for going through and comparing all those duplicate or triplicate in some cases clauses which really cleaned that standard up. So I appreciate all your work on that, Mark. And next is Rob Anderson, who has the residential task force. Thank you, Rob.
Thanks. Yeah. So Rob Andershook, I'm chair of the residential task force. I've been involved with the CSA standard for 20 plus years. Our job basically was going through the residential section, and to echo what Mark said, is get rid of a lot of the redundancy, and especially where there is contradiction. So we sent a lot of stuff from the residential section over to the general section, and a lot of information that was in the, or a lot of the requirements in the residential section, we moved to the various appropriate subsections, whether it was horizontal or vertical systems, or open systems, or heat transfer fluids. So that was a lot of the work to take stuff out. And then the other part, and again, to echo what Mark said, was try to make it as performance-based as possible and remove prescriptive requirements that may be applicable in some areas, but may not be applicable in other areas, especially now with the binational standard. And the only, well, the most significant change in the residential section, it was originally a Canadian-based standard, and we had a minimum entering water temperature. So a lot of the issues we've seen in the field were ground loops running, below 20 Fahrenheit. And the old standard, you could install it to the standard and still get systems that would have incredibly low entering water temperature. So from a performance-based perspective, there's a minimum entering water temperature requirement in the standard from a heating perspective. But we added a maximum entering water temperature. Jeff Hammond was key to that. And so on a cooling base, so that really completed the residential section. And it really helps with designers, auditors, inspectors to have that minimum or maximum entering water temperature number when they're verifying the system. So anyway, that's the residential section, and I'm done.
Thanks so much, Rob. All right. Well, I was the task force lead for the commercial section, so I'll take the lead here. The commercial task force was relatively large. We had 21 members of that task force, and incredible discussions. We met from May 2021 to May 2023. I don't remember exactly how many meetings it was, but we had a lot of meetings and a lot of really good discussions. One of the things the commercial task force did was we reviewed the IGSHPA Standards Committee recommendations for the standard. As I mentioned, IGSHPA is sunsetting the 2017 standards once this 2025 edition is published. And so the IGSHPA Standards Committee had a list of items to consider. A lot of them fell into the commercial section. So we went through all of those recommendations. When we updated clauses and so forth, we also updated a lot of the clauses for consistency of terminology. I didn't realize how many different ways we could say ground source heat pump, but there were a lot of different ways. So that was really good. We also made sure that the clauses were performance-based rather than prescriptive as much as we could. In that commercial section, we went through a number of the clauses in the design and commissioning clauses that we rewrote to align with the ASHRAE requirements. We had a really good mix of people on this commercial task force, and many of whom were also ASHRAE members. So we had a lot of good resources there. We initially had district energy systems as part of commercial. It seemed to fit in the commercial section. But as we started talking about district energy systems, almost every clause had to be changed in order to incorporate district energy systems. So probably halfway through our commercial meetings, we decided that it just didn't make any sense really to include district in commercial. And then a new section was created for district energy sections, which Lisa Malin will go through here shortly. So that was something that we spent quite a bit of time on. And as Rob said, a lot of the sections that were duplicative, we moved over to the general section. So you'll see the commercial section got shorter, as did most of the sections, and the general section got way larger for that very reason. So it looks like next on our list is district energy systems. Lisa Malin.
Good morning, everybody. Lisa Malin from Malin Engineering in Sacramento, California. I'm going to give you a quick overview of the district energy system section, which is brand new, as Jeff talked about. Was really fortunate that when we finally decided to peel off commercial, I had a really great sub task force out of commercial to work on this, and we actually worked through the content, believe it or not, in about 6 months. It was a very dedicated and efficient team, and I think you'll be really happy with what we've come up with. It is our first the first stab at it, and one of the things that I did want to mention is that first of all, what to even call this section. You know, there's a lot of different nomenclature being used for what we're talking about in the industry currently, and we decided to use district energy instead of using district geothermal or some of the other things out there, because it really is just another way of sharing thermal energy between buildings. So what I want to say is that district energy systems are inclusive. We're also trying to be inclusive of any possible type of system design that could be created. It includes ambient temperature loop systems, central plant systems, combination systems, which we envision when people try to retrofit district with existing buildings, and it can also include on-site generation of power. So we and energy storage. So we really wanted to look out to the future and see how many different ways these things could be created and make sure we provided for that. What this section does not include are anything relative to the heat sources or sinks, because those are already covered by other sections. What it does include are specific information about distribution piping, which is going to be different in most cases than what you might allow for, say, a single building and a single ground heat exchanger. So there's a wider palette of opportunity for piping, including pre-insulated piping, which you may need in some cold regions. But one thing that I do want to mirror in an earlier discussion is that no CPVC or PVC, we decided to take that out of the options, even for distribution piping, just for long-term reliability. So even though your building code may allow it, your mechanical code, we are not recommending it for the district systems. And so just to give you an idea of how we've defined district energy systems, I want to go ahead and read the definition here. It's a system characterized by one or more central plants distributing ambient water, hot water, water-based solutions, steam, and or chilled water, which then flows through a network of pipes to provide hot water, space heating, and or air conditioning for multiple buildings. And just to be clear, central plants are inclusive of pumping stations or plants. And so all this can be employed as part of a district energy system where we're using also the earth, groundwater, and or surface water as a source or sink in the distribution system. So it's really wide open. This section also includes all the things that are not covered in the clause 5 of the other sections, because we've got additional equipment like thermal storage tanks, we've got energy transfer stations, we have different types of communication systems, including SCADA. So we wanted to make sure all of that was included in this district energy system section. And I think that's probably enough. You can read the full-length version when it comes out next year. Thank you.
Thank you, Lisa, for all your hard work on that. It certainly was a transition from where we started in commercial, that's for sure. All right, our next section is vertical ground heat exchangers with Jack Henrik.
Hey, my name is Jack Henrik. I'm with Bergerson Caswell. We're a contractor in Minnesota. And as Lisa said, if you have any questions on the closed vertical loop area, wait till it comes out. I was lucky enough to work on the vertical loop rewrite in 2016, and that group decided they wanted to be very prescriptive and cover everything. And as Mark told you, we're more of a standard than we are prescriptive. So a lot of the stuff that was in the vertical loop area has been moved into general. So it's very important that the general section, that everybody remembers to check that general section very closely and then look for the specifics on the different areas with them. There were 14 members on my group, and if you listen to Jeff, he had 21. That's 35 out of 75. That must mean Lisa worked all by herself. No, not really, because there were so many of the people that worked. They worked on more, 2 through. I don't know how many Lisa was on, but there were people that worked on 4 and 5 different groups. We had a fairly even split between Canadian members and U.S. members. We had engineers, designers, installers, hybrids, and we also had Lance. Lance is a very good resource for just about everything. And I have to take my hat off also to Andrew. There were a lot of times that when we were having discussions on things that had happened a year and a half ago, Andrew could look that up right away and get us back on track. The issue that we saw as the most important in closed vertical loops is that the size of the systems are getting bigger. And when I say bigger, I mean taking up more surface area, and especially in Canada, they're getting deeper. And that causes a problem because I work both with the National Groundwater Association and IGSHPA, and they recognize that sealing of these loops properly, either during construction or during abandonment, is a very large issue that has to be addressed. And Mark did a great job in the general section addressing that to keep it as a standard. And so with that, that's about all. Other than working with all these people is a very rewarding experience. I think every time we had a conference call, I learned something. So I would like to thank my group. That's all for me.
Thank you, Jack. Yeah, great working with you on that. And your experience is a huge help for sure. I don't know if Ed Lorenz has joined us yet or not. Chair for the horizontal task force. I haven't seen him, so I think we'll skip his section and come back later in the webinar. So our next one then is surface water ground heat exchangers. Lisa again.
Hi, me again. um, this section is one that I volunteered for. I was really interested in getting into the details of surface water designs, which I have done, but there's really 3 things to share here. First of all, we mostly did a housekeeping review of the section. We went through and reorganized things to align better with the format that the other sections were using. And because we did have a lot of information or guidance in there, minimum requirements, things like that for the design of the systems, we opted to change the title. So it's now design and installation of surface water heat pump systems. The second thing that was important is that I had a meeting with Jeff Coibel, who is the task force lead on the groundwater section, and we really wanted to make sure that we drew the line between what he was doing and what I was doing. And so included in this section is submerged surface water heat exchangers, submerged and above ground, which are connected to a ground source heat pump system and used as a thermal source or sink for heating and cooling applications. So we really wanted to make sure that there was a delineation between groundwater and surface water. Let's see, I had one other thing. Oh, we did also make sure that there was content in here about folks that are using plate and frame heat exchangers, submerged heat exchangers, in the bottom of lakes and things. And so we added some content there about, factory testing and how to inspect those systems and things like that. So we had a great team. It was a very small team. I think we ended up having 5. And we were the first one over the finish line, finishing our section April of whatever after the first year we started it. I don't remember which year. It's been a long time coming, but very good section. And I will now turn it over to the next person.
Thank you, Lisa. So our next section is groundwater systems. I think that used to be called open loop, if I remember right. And that's Jeff Coibel.
Good morning, everybody. Jeff Coibel. I was the chair of the Groundwater Systems Task Force. I'm based in Western Canada. I have a background in ground source heat pump system design, as well as a previous career as a groundwater engineer. There was previously, as Jeff Hammond had alluded, there was previously a groundwater open loop section. It was quite generic and quite skinny. So the content in this section now, it's almost all new content. So it is quite an extensive update of the section. Some of the highlights of what was done, it recognizes that the suitability for the groundwater systems is really quite site-specific dependent. And it also recognizes that, so it includes a description of a staged evaluation approach for evaluating those sites that are suitable for groundwater system application. And it includes description of design and control strategies. Our task force reached out really early on for collaboration from the National Groundwater Association and the NGWA appointed Ron Peterson to participate in this initiative, and we were really, really pleased and appreciate the efforts that were provided on behalf of the National Groundwater Association, and in fact, all of the other outstanding efforts of the task force members. One of the overarching considerations in the work that we were doing is that the protection of groundwater resources is really, really important. And yeah, the work that we did really, really aimed to reflect that throughout. And at that, I think I will wrap and pass it on to the next.
Thank you, Jeff. All right, our next presenter is Carl Oreo on standing column wells, and we're fortunate to have Carl's experience. I think you might have done just a few of these, Carl, over the years.
Thank you very much, Jeff. Thanks very, very much for all identifying the 8 people that were on our task force, some more than others, and we really appreciated all of it. The big thing that we did here was break up the standing column wells into the 2 major components. One, the residential component, which is somewhere between 1 and 8 tons on a single bore, and then recognizing that there's a split off and a change in design when you're going up to 30 tons on a single bore, which is what we look at. Actually, we've got as much as 40 tons. We were lucky to have the Stodoff drillers that did about 3 dozen standing column wells in downtown New York City, including St. Patrick's Cathedral, and they were seeing probably more and more advantages for those deep 30-ton wells. We broke it also into recognizing that, as noted before, site-specific means a lot more and more for us every day. And I certainly make that as an appeal to anybody that's in the trades. Look at what you've got underground. Standing columns are most useful when the bedrock is within about 200 feet of the surface. When we go deeper than that, we have to have more casing, we get more costs. Otherwise, we can hold our costs to about 30% less than a closed loop system. With this clear distinction, we removed any ambiguity between residential and commercial designs. We did add it and felt very strongly about the whole system package. And we looked at the interface with the buildings and in particularly talked about a life cycle maintenance. There's a responsibility that gets fallen back onto the owner. And that owner, if they don't follow the responsibility that we should specify to them, we get blamed, of course, if the system goes over the hill. So I want to thank everybody that was involved. We have very pleased that we're able to put some single line sketches into our standard definitions because has been a lot of confusion between residential and commercial. We also talked about some of the faulty electrical systems and open well systems. We had the same sort of problem that exists, and I want to also thank you, Jeff and I had a lot of conversation back and forth, and thank you, Jeff. Hopefully we were able to do some contribution into yours. Thank you all. I'm looking forward to the final destination of 448.
Thank you, Carl. And that reminds me, we do have some graphics now. We didn't have any graphics in the previous edition, so that's great that we have a little bit more than just text. So our next section is a brand new section, Energy Foundation, ground heat exchangers, and that's Tony Amos.
Yeah, thanks, Jeff, and good morning, good afternoon, good evening, wherever you're dialing in from. I'm going to be cheeky, and I'm going to just flash up a slide. Hopefully you can see that. So when I came to the US 7 years ago, everybody was talking about where we're going to drill boreholes, and I think it's absolutely fantastic that this committee group have sort of got together and shown the multivarious solutions that are kind of now available to the US and the world. So very pleased to kind of be part of the foundation standard development, and basically this kind of covers all of the new construction opportunities around the country and the world even. There's lots of different types of foundation being constructed, depends on ground conditions, largely highly contaminated ground conditions. There's a displacement pile technique where there's no material coming out of the ground. And predominantly there's a piece of reinforcement that is being installed in all these piles, and it's simply a case of adding reinforcement to adding a geothermal loop to that piece of reinforcement. And lo and behold, there's a fantastic opportunity to deliver heating and cooling. There's a couple of projects here in New York where foundations to buildings down to 140 feet will deliver somewhere between 70 and 80% of the building's heating and cooling. And every time I go to JFK Airport, I see them driving in steel tubes in the ground. I just think there's another opportunity being missed here. So yeah, so the standard that we developed was we kind of utilized what we developed in the UK through the Ground Source Heat Pump Association standard. I got Michael Chenderain from Arups and Fleur Loveridge from Leeds University involved in developing the kind of the standard, both of which were involved in that Ground Source Heat Pump Association standard, and they brought in some important elements. Fleur especially, and one of the things that we need to be mindful of with perhaps conductivity testing an energy foundation opportunity is how many loops are in the pile, the diameter of the pile, and Fleur Loveridge from Leeds University she's got a lot of papers that she's done providing some good sort of information on how that should be brought about. So we've incorporated that within the standard. Yeah, I think that's, the key nuances here is the early collaboration with the geotechnical teams. We're not looking about changing anything about the foundation detail. So collaboration is key to begin with, but then as you move into the construction phases, how you are then needing to interact with the kind of site teams to ensure that, this kind of solution can be installed without any impact to the construction schedule, ultimately. Massive thanks to Andrew Kostruba, who kept us on the straight and narrow. I can't use the words shall, should, and could without thinking about Andrew and the implications of what each of those words mean. And yeah, so thanks to also the team here. In addition to Michael and Fleur, were Ed Lorenz and also David Stotoff, provided important input into that standard. So yeah, I shall stop sharing my screen and back to you, Jeff, and on to the next person.
Thank you, Tony. Yeah, we had truly an international team here. So that was really some great conversations. Absolutely. Thank you, Tony. Our next section is direct expansion heat pumps, Craig Bushner.
Hey, everybody. I'm Craig Busher from Total Green Manufacturing, located here in Ohio. Just wanted to express our thanks for being involved with the development of the standard. Like everybody said before, it was just tremendous group effort of updating something that's so vital to so many people and so much room for update and improvement. So we took and I headed up the direct expansion group, or sometimes referred to as DGX or DX. Basically, we just cleaned it up. We got rid of a lot of repetition, brought it up to date. We had a great team effort. So we had some guys from Canada in there. We had some guys from the United States in there, just all over the country. So just a great effort. I want to thank all those guys. And as far as the changes that we made, we just wanted to make sure to clarify the grade of copper. With the geothermal direct exchange small footprint, it really can work in a lot of fantastic places, but the quality has to be maintained. And so we wanted to be sure that they utilize the right grade of copper, that it followed the ASTM standards and ASME, so B280, and just making sure that we get quality, right? We're all after that, and we all strive it. And as this standard notes, that's what we're really after, trying to make sure that everybody gets a quality job and top quality performance. So we were really thrilled to be involved with it. We were really thrilled to get the updates. And I think overall, I think the C448 project this time involved and reached out to all the current technologies that were making a huge impact in this world, in this technology, in this field all around the world. So, I mean, I think we were glad to be involved. We made sure that to maintain the integrity for direct exchange systems, that they use the right copper, the right silver braze, the right pressure testing, to be sure that all of that is done in the right ways, and loop sizing and stuff, just to be sure that all the manufacturers, you're matched up with the manufacturers, and that designs are not overlooked, and that we keep the cathodic protection systems to ensure safe, long lives, I should say. And, that we're grouting that shut, making sure everything's sealed. There's no safety concerns for the water tables and things that way. So just a lot of great savings for the homeowners and huge benefits in cutting our carbon footprint. And once again, just shout out to our whole team and Jeff for doing such a great job of keeping this all going. Andrew, again, was a big help for our group as well. And so thanks again, guys. Appreciate us letting us be involved and engaging in every way we could. So I'll pass that on.
Thank you, Craig. All right, so looks like our next section is really an annex. We have the new Annex E, which is wastewater energy transfer, and that's Lisa again.
Yeah, third time's a charm. I promise this is the last time. So this was a very interesting project. I had really wanted to work on incorporating these wastewater energy transfer systems. We're basically talking about sewage systems, right? And seeing a lot of activity in the industry, but there wasn't a lot of guidance out there. So Jeff and Mark decided that this would be an annex, which means it's voluntary. It's not, required as part of the standard. And the first thing we did is just trying to define what is all inclusive in this technology. And there's basically three different types of systems. There's an in-pipe or in-trench type of system where you're doing a heat transfer exchange with the pipe, or the pipe within a trench. There's in-tank or in-channel heat exchangers where you're actually placing the heat exchanger within the waste stream, whether that be in the building or actually in the distribution system. And then there are pump systems where you're actually pumping the waste into a heat exchanger using that energy and then discharging. And there's a lot of moving parts here, especially when you're dealing with the waste side or the effluent side of the wastewater treatment plant. There's some things to consider. And so looking into this topic, I was very fortunate to be assigned a very international team. In fact, a couple of my task Force members were from Germany, which became very helpful because the only document I could find that had any kind of guidance or even an existing standard on this topic was out of Germany. So I had to get help from my German colleague to get this thing ordered and purchased. And then Jeff Hammond graciously interpreted it for me so that we could use it as a reference document as we created this Annex E. So there's some basic guidance here that you can look over, but as far as if you are going to do one of these kinds of systems, and obviously the manufacturers of some of these systems are going to be a good resource to you as well. But I wanted to be clear about what this is and is not. So included in this annex are wastewater energy exchangers within a building or the effluent from a building site, okay, or a facility, sanitary sewer, combined sewer, and stormwater. So these are all waste streams. The distribution or network level is the focus of the annex. So that's what's included, and what is not included is kind of the clean side of that system. So once the waste has gone through treatment and is discharged into, you know, a river or whatever, we're not dealing with that side of it. And that would actually most likely come under the jurisdiction in this standard of surface water, or maybe, I don't know, Jeff, maybe groundwater. But that's how we defined it. I'm really anxious to hear what all of you think and give us feedback and decide if this is something we feel is important enough to start beefing up and pulling into the mainstream standard. So that is all I have there. Thank you, Jeff.
Thank you, Lisa. And the next three task forces are not actual sections or annexes. They support the various sections. So we have the piping task force, the heat transfer fluid task force, and the thermal conductivity testing task force. Those all worked with the various sections as subject matter experts. I don't believe I've seen Lance McNevin. Are you here, Lance, to talk about that?
I'm here.
Oh, you're here. Okay, I didn't see you. I'm sorry. All yours.
All right, thanks, Jeff. Hi, everybody. I'm Lance McNevin with the Plastics Pipe Institute, a nonprofit trade association. So the Piping Task Force was first formed in early 2021, in the early days of this project, and ended up having a total of 13 task group meetings over a couple of year period. We finished our work in June of 23. The Piping Task Force was made up of 10 people, including pipe manufacturers, but other interested parties as well. Mark Metzner was part of that and sat in pretty much all of those meetings too. And then the goal of our work was to then take our piping work and then turn it over to Mark's C448.0 group for general requirements. So the work was developed within the Piping Task Force and then reviewed and approved and in some cases edited within the 0.0 task force. So some of the high level things that is new in the piping is obviously we still have HDPE pipe as our primary piping material. There's a couple of new requirements for the HDPE pipe. Now it's required to also meet an NSF standard called 358-1, and that's a standard specifically written for geothermal polyethylene pipe that also requires the manufacturer prove that the pipe is compatible with different antifreeze mixtures and some other test requirements. So that's now going to be mandatory for the pipe manufacturers to meet. And then the other new mandatory technical requirement is the pipes are certified to NSF 61, which is the standard to prove that the pipes are safe for drinking water. Not that we're passing our drinking water through these pipes in most cases, but the pipes are actually passing into the drinking water, especially if you're pushing the pipes through boreholes, passing through aquifers, or through surface water, lakes and ponds. We want to make sure that the pipe is actually safe for contact with the drinking water and won't impact that in any way. So the requirements for the polyethylene pipe are increased. There's more clarity there. And then there's also two other types of piping materials. The next section allows polyethylene of raised temperature pipe to be used, PERT. PERT is HDPE pipe, but it's a special blend of HDPE pipe that can actually withstand higher temperatures. Normally you don't need that, but if there is a system that is going to be used for underground thermal storage or something like that, PERT might be the right product because it has higher pressure and temperature capabilities. And then the third type of pipe material allowed here is crosslink polyethylene, which was allowed in the 2016 edition. And the fitting systems for use with crosslink polyethylene are updated. PEX is also HDPE. It's an even higher grade of HDPE with higher temperature capabilities and almost infinite resistance to slow crack growth and any kind of damage like that. There's also a section here at the beginning that allows alternative pipe materials. So if a new type of pipe is invented between now and the next edition, and it meets all the important performance requirements, there's a section in here that gives the designer guidance towards allowing the use of alternative pipe materials as well. There's a lot of other details I won't go into now. Again, you will see that when the new edition comes out, but definitely want to thank Jeff and Mark and Andrew for all the guidance and facilitation through this big, long process. But we're really proud of the end product here. So we hope you all like it. Thanks.
Thank you, Lance. That's definitely outside of my expertise. So I appreciate all your hard work and your task force. All right, our next task force is the Heat Transfer Fluid Task Force. Jerry Lewis.
Hello to all. My name is Jerry Lewis. I work for Kilfrost, and we sell heat transfer fluids and aircraft de-icing fluids. We had a relatively small group. There was 9 of us working on this particular task force. We had lots of arguments, which I was pleased with, simply because it made us all think, what were we writing and how well were we doing with it? I think the group itself eventually worked itself into something which was quite presentable. It was obviously the consolidation of heat transfer fluids with several sections in the previous standard, 3 or 4 different places where heat transfer fluids were mentioned. So this was really a consolidation and updating exercise for heat transfer fluids. As we all know, the best heat transfer fluid that you can get is water by itself. Unfortunately, it does have its downside of freezing, encouraging corrosion and encouraging biological growth. So the way forward with these things is always to come up with a formulated product, something which takes care of the downsides of the aqueous fluid itself. And typically glycols are used as the antifreeze. And whether the glycols, the inhibitors are added in there to make a fully formulated product which covers all of the bases. It's not as good in terms of heat transfer as water by itself, but inevitably we have to do these sorts of trade-offs to get something which is practical. So the fluid section essentially came down to 3 different headings. System preparation, making sure that the thing is put together right. There's also some pressure testing. I think that went to a different section, but really the system preparation is making sure the thing is put together, doesn't have any tramp stuff kicking around in it, and it's not infected with anything biological. System preparation, first of all. Water quality was a fascinating section simply because of the number of arguments we had. We put things in, we put things out, and then we consolidated them back in again. So the actual water quality was quite a good argument. And I think what we ended up with was something which is useful for all. After system preparation, water quality, we have also listed out some of the typical commercial fluid types. Essentially, this is an update of Tapscott and Heinonen, the report from about 25 years ago. So what you'll see there are the various ways in which we've thought about the fluids, how they need to perform, and to give you an idea of the trade-offs between one fluid and the other. So I think straightforwardly, system preparation, water quality, a list of some of the typical commercial fluids, fits into general as an overall descriptor, much better than having it scattered throughout the script. Again, all feedback is welcome for this. One last thing I'd like to do is to echo Lance and to say that Jeff, Mark and Andrew have been towers of strength and patience while we've gone through this process, and I thank them very highly. I also thank you for your time, and I'll hand back to Jeff.
Thank you, Jerry. Great to see those updates for sure. And last but not least, we have the Thermal Conductivity Testing Task Force with Terry Proffer that rounds out our task forces. Terry?
Thank you, Jeff, and do appreciate the opportunity to discuss our new TC test standard for the CSA 448. First, I'm just to let anyone know who I am. I'm the manager for Major Geothermal out of Wheat Ridge, Colorado, which is in the Denver area. And we design ground source heat pump, ground loop systems, and that sort of thing. Also, just like to, we didn't have a huge committee. So I just like to reference the folks that were on our committee, and I think it's important for those listening to this presentation that we had some pretty experienced people to help out with the TC test standard. One was Steve Kavanaugh, who's an ASHRAE author. Those of you that are into commercial ground loop designs probably have his commercial design manual on your desk right now from the Department of Engineering, University of Alabama. We also had Chad Martin and Galen Strike from GRTI on the committee. You know, these guys, that is their business, thermal conductivity testing. We had Stan Rietzma from Geosource Energy out of Toronto helping us. Andrew Stump from Illinois State Geological Survey contributed. We also had Rick Clemenzi from Asheville Geothermal and Garen Eubank from Eubank Geotesting contributing on this committee. So when I first was approached to chair this committee, I had never really read up on the test standard from the 2016 or the last CSA 448. When I read it, I was not, it was lacking. So one of the things that our committee did was we identified that, you know, we need to look at the line source testing procedure, which is pretty much the industry standard. And the previous standard language, we had to heavily massage it, and some parts were just eliminated. The reason for this is the language was not consistent with typical design procedures and other real world considerations. So we pretty much started with a clean slate. We also relied heavily on the ASHRAE Research Project Report 1118, published in May of 2001. And the principal investigator was Dr. Steve Kavanaugh, and the primary authors were Chad Martin and Land Zai, if I'm getting his name correct. Anyways, so that's been around for 23, 24 years, and it's a defensible procedure for TC testing called the line source method, and that can be applied to both vertical and horizontally drilled boreholes. We also touched on how the test parameters should be determined, which, even though this is a standard and we're not getting into how to design a system, we felt it was necessary for people to understand that you just don't go out and drill a hole randomly and assume the TC and undisturbed temperature values are going to be the same at different depths. The other thing is the cost of a TC test is pretty expensive these days. It's not necessarily the time to run the test, it's the cost of getting the driller out there drilling a single test hole or more if it's a project large enough that requires multiple borehole tests. You don't want to waste those boreholes, and you want the parameters to be selected correctly. That is, where they can they're all going to be consistent with design depth of the project, that sort of thing. And the other thing is you don't want to throw that test hole away. If, you know, some of these TC tests are running due to mobilization for a drill rig, maybe $30,000 to $40,000 in some worst cases. So we want to integrate that test hole into the operating field later. So those were some of the things we touched on. I'm really indebted to our people on our committee because we hashed out a lot of stuff. I think we've got a very, very good standard now. It actually reflects real world design considerations and how you go about programming a TC test. With that, I'll let Jeff have back.
Thank you so much, Terry. I apologize, we went a bit over. You can see we have a lot of passionate people on these committees. I believe we had over 70 people on these task forces. So we have the industry experts and people who are just really dedicated to having a great standard. So I want to give a hand to all of the task forces and their chairs for all the effort. Andrew Kostruba just was incredible, as I mentioned earlier, at leading this. And CSA Group has really done a fantastic job of making sure that we who are passionate and want to get this out here are also following all the protocols of what a standard should be. So I think when this is published in really just a few short months, it is going to be a big difference for our industry. And the fact that we're sunsetting the IGSHPA standards really helps us with consistency. So thanks so much for participating, all of the presenters today, and all your hard work on the standard. Thank you for joining us in the audience. We did have some questions and comments, and thank you, Andrew, for responding to those, because we are pretty much out of time, but great conversations, and this will be recorded and posted on the IGSHPA website, IGSHPA.org, in the next couple of days. So thanks again. Have a great weekend. And if we can be of any help, let us know at IGSHPA. See ya.